Hey everyone, welcome to AC Academy, and today we are going to review Algebra 1, Section 1.2.3, and that's graphing transformations from a parent function. Okay, let's get into it. Question 1 states a linear function, f of x equals x, or y equals x, is graphed on a coordinate plane. A new line is plotted by changing the slope of the original line to 2 over 3 and the y-intercept to 4. Describe the transformation to the graph. Okay, so first thing, we have our equation, or rather our given linear function or our parent function, f of x is equal to x. So function of x is equal to x, right? In this case, this is the same thing as y equals x. Now, this equation is using the standard format of an equation, right? The standard like linear format, and that is y equals mx plus b, where m is your slope and b is your y-intercept. Okay, now looking at this equation here, first equation, this, rewriting it in this standard format, I'll note with 3 dots, we have y equals, and comparing these two, mx, which in this case m is going to equal 1. So 1, same thing as m, x, plus b. B in this case, there's no b, so b equals 0. Right, so here's our first equation, equation number 1. Our parent equation, y equals x, right? And then that's going to be, looking at this plot, we're going to graph that in black. So y is equal to x. Sorry, let me get above that layer. I'm going to skip a few points here because it's pretty... every y value is going to equal every x value, right? The same thing with the negative values. You have negative 1, x equals negative 1y, negative 4x equals negative 4y, negative 8x equals negative 8y. And then we're going to plot this here. Sorry, that's a little crooked, but you get the point. All right. Now, let's make equation 2, right? And equation 2 we're going to make in blue. All right. It says the slope changed to 2 over 3 and the y-intercept to 4. Looking at the standard format again here, y equals mx plus b. So this new equation, y equals mx, m, it states here that the slope is 2 over 3. So 2 over 3 x plus, and the y-intercept to 4. 4. So I guess how do I plug these values in? We look at the standard equation. We know m is the slope of the line and b is the y-intercept, because whenever x equals 0, this value goes to 0, and y equals this number when x equals 0, and that's right on the y-axis. So that's your y-intercept. Okay, so if we want to plot this blue equation, we know that whenever x equals 0, y equals 4, right here. And you could do this in you could do this in multiple ways, but one way I would recommend, if you are in maybe a rush, or maybe you don't have a calculator on you, or maybe you just can't do this math in your head, which either way is fine. One option is to write an XY table. So you could do whenever x equals 0, y equals 4. Whenever x equals 1, y equals 2 over 3 times 1, because we're plugging in x into this equation, plus 4, right? Whenever x equals 2, y equals 2 over 3 times 2, plus 4, and so on. Whenever x, like you go all the way down to, let's say x equals n. n can be a made-up number, any number. You'll have 2 over 3. Y is equal to 2 over 3 times n plus 4, right? Okay, now if you don't have a calculator, can't do these numbers, or maybe you're on a time test, you know that the slope is m equals rise over run, and we will just plot that here. So we start at 4, 0. We rise 2, and we go over 3. 1, 2, 3. Rise 2, we'll go over 3. Rise 2, go over 3. Right? Same thing, rise -2, go over -3. Rise -2, go over -3. -2, -3. Then we plot this line. And if this were to keep going, it would eventually cross somewhere over there. Okay, so describe the transformation from y equals x, which is this one, and y equals 2 over 3 times x plus 4. So first, the y-intercept increased, right? We went from, I'm trying to do this in a different color just so you can see whatever changes I'm making. We went from a y-intercept of x equals 0, a y-intercept of, whenever x equals 0, y equals 0, to a translated y-intercept of whenever x equals 0, y equals 4, right? So we increased 4. Now let's look at the slope portion of the equation. We noticed that our equation became less steep, right? Our slope originally went from 1 to 2 over 3. So our slope decreased. So we are not, our rate of change here is not as great whenever we increase x, right? So this initial equation, y equals x, our rate of change was 1x to 1y. For the second equation, our rate of change is 2/3 that, right? So it's for every 2 you increase, or rather, for every 3 you go over an x, you get 2 in y. So the rate of change, I guess, with respect to y isn't as great as the first equation. And that's mainly the difference between the two equations. So for the equation with the lower slope, and by lower I mean as compared to 1 here, the 2/3 slope means your rate of change, or your slope here, is less steep. And the line is also shifted up 4. So that's what you would do to describe this equation with these changes here. All right. Let me know if you have questions over that, and I can go into more detail in the comment sections, or I can make a follow-up video there. If we go to the second problem here, the problem states a student graphed f of x equals x and h of x equals f of x plus 3 on the same plot. Describe how the plots are related. So we have our equation number 1, and that's going to be f of x is equal to x, or it's going to be y is equal to x. And equation 2, h of x is equal to f of x plus 3. F of x equals x, so let's plug that in. H of x equals x plus 3. Okay. And again, let's plot the two equations. We'll do equation 1 in black, and then equation 2 in red. So we just plotted y equals x on the above graph, so I'm going to skip a few points there and just kind of line up two of the extremes and draw a line. There and there. And the same thing here, we look at h of x, which is x plus 3. We're going to plot that in red, which it is the same plot as f of x, as in we have the same slope. The slope equals 1. We're just translated up 3 units, right? So our y-intercept went from 0, which is f of x equals x plus 0, which is, that's our y-intercept, to x plus 3. Again, using the f of x or y equals mx plus b, where m is the slope and b is the y-intercept, right? Okay, so plotting that second equation in red, we go up 3 here, and then it's the same thing, right? So we go 1 to 1 changing because our slope is 1, which is rise over run. Ooh. There and so forth, right? Okay, describe how the plots are related. Now, the plots, looking at the plot here, are the same thing. They have the same slope. So 1, same slope. 2, they are the second h of x is translated up 3 units. So it's shifted up 3. Okay, and that's how the two plots are related. These two lines are also parallel to each other, and they won't intersect, right? Because they have the same slope, so it's not like one has, I'm going to draw this in blue. If these equations didn't have the same slope, let's say this bottom one was like 5x, right? Then that would mean the slope is 5 over 1, so it would rise up 5 and go over 1, right? Sorry, let me do this in blue. If it was 5 over 1, we'd have that, and we have 10, and it'd be something like, be something like this. And these lines wouldn't be parallel because they have different slopes, and this slope right here would intersect the second equation. But since these two have the same slope and one's just shifted up, they are parallel. So that's all for this lesson. Let me know if you have any questions. I know some of this might be a little confusing because there's a lot of different ways you can do these problems. Now, if you have any input or questions or any specific problems that you're working out that you have questions on, go ahead and put them in the comment section, and I will get to them as fast as I can. Anyway, thanks for watching, and hopefully I will see you soon in the next video.